Everybody, I just want to do a quick overview of the topics that we'll cover in AAP, the Advanced Analytics with Python course. So I'm going to go out to our course web, and so this is the public part of our course web. Most of you have probably had me in the PCDA class when I was already using, a combination of Moodle and then a public course web as well. If not, then you'll get the hang of it quite quickly. And remember, this has nothing to do with your OU logins of any sort. This is always accessible to you from wherever, whenever. And in fact, also just remember, the easiest thing to do is if you search ISC in Oakland and go to my teaching page. I always keep my current course websites at the top, so there will be a link for this course, and usually I leave a couple years of them out there. And so this is Module 1, Analytical and Technical Foundation, the very first submodule getting started with AAP. One thing I said I'd do is give you a quick preview of the topic, so that's what I'm going to do. And the easiest place to do that is from the syllabus. Just click the syllabus link. I've already got it open over here. If we scroll down there's a detailed course calendar that's got kind of an overview at the top of it. So again, we'll kind of basically spend a week just getting up to speed with a kind of a technical foundation. Make sure you got your machine ready to go. Refresher on Jupyter Notebooks and Jupyter Lab, Git and GitHub. I'm starting to use PyCharm, or if you want to use a different IDE. So this will kind of take us, through the first week of the course, and then we'll do a module on machine learning. And so this is kind of where the PCDA class ended. We learned a little bit of scikit-learn or sklearn, and we will, kind of pick up there and do some advanced techniques, but also kind of some more software engineering kinds of things, project management kinds of things. We'll learn about cookie cutters and to set up good project structures, and we'll learn about some features of sklearn that make it easy to do modeling, such as pipelines. We'll see how you can deploy notebooks via things like Binder. And we'll take a look at some slightly more advanced machine learning techniques, regularization, which is actually kind of goes along with regression, and then gradient boosting, which is a kind of a flavor of tree-based models. Well, it's actually more general than that, but and these have been very popular and very successful in things like Kaggle competitions. It's good to understand, kind of how these things work. So we'll I've got a kind of plan for a week. We'll see if we bleed over, a little bit. And again, everything's kind of subject to change. It's the first time I'm teaching it. We'll kind of see how things are going timing wise. And then we're going to kind of do a section on kind of the relationship between Excel and Python. And we'll do things like things we might normally do in Excel, especially if you had the spreadsheet class with me. We did things like data tables and GoalSeek and building models. And how might you actually do those in Python? Monte Carlo simulation even. And then kind of along the way, we're going to be, you'll see as we kind of go through this, we'll really be cranking up our Python skills in the sense of using more advanced techniques. We'll do an overview and start to learn how to do object-oriented programming within Python. And how to actually then start to think about deploying things as Python packages, and then we'll do some stuff, using Python and pandas for kind of data-related things that you might normally do in Excel. And then we'll shift over and do a bit on simulation modeling. I said one big theme of this course is that it's really easy these days to get kind of wrapped up in thinking that machine learning is synonymous with analytics, and it's really not. I mean, it's one technique for one, or a family of techniques for one kind of big class of problems. But there are a lot of problems where just you might not have a lot of data to to build machine learning models. And often things like simulation are really useful when you're trying to do what if on systems that don't really even exist yet. So we'll do a little bit of discrete event simulation modeling. Some of you may have taken the operations analytics course and done this in Simio. We're going to use a Python package called SymPy. We'll build a vaccine clinic model. And along the way, we'll again kind of learn some additional more kind of software engineering-ish things, like how to build a command line interface so you can run your models from the command line, how to do logging, and kind of setting up a workflow for conducting simulation experiments via Python. And then I hope also to do a little bit on another flavor of simulation known as agent-based modeling. And you may have seen these. Certainly during the pandemic, there was a very, very famous article in the Washington Post that showed a little agent-based model. And so these are where, it looks like a swarm of things moving around, little dots, which are people, and they're infecting other people and all that kind of stuff. So these are known as agent-based models. And Mesa is a Python package that allows you to build those pretty easily. So I'd like to introduce that. It's an interesting, modeling technique. We'll see how we're doing time-wise, because I also want to, in the PCDA class, the web scraping often kind of fell off. We just never really had time for it, or it was done very quickly, so I'd like to take a little bit of time with that. So I'll be adding screencasts to this session. Right now, it's just Jupyter Notebooks. And then hopefully do a little bit also on kind of interacting with databases from Python. And then also kind of in this general data wrangling section, digging into some date time analysis things. If you do business analytics, you're often dealing with dates and times. And they can be tricky in Python, and also just be tricky in general analytically. As part of this, I'll share, the open source project Hillmaker that I have. It does a specific kind of date time analysis related thing, and we'll learn a little bit about software testing, things like PyTest. And then if we still have time, if we've managed to actually just do all this, I thought the last kind of interesting advanced analytics thing would be optimization. And again, this is a whole other class of problems that aren't solvable by machine learning, though actually under the hood, most of machine learning is actually based on optimization. But we'll look at optimization applied directly to business problems, things like routing and scheduling problems. When you're trying to find the best way to do something, those aren't machine learning problems; those are optimization problems. And there's a package called Pyomo in Python, which is an algebraic modeling language. So, if you built models in Excel with Solver, instead of doing that kind of model building, we'll literally use Python to build the model. And hopefully, maybe we'll try to do a model that is, something like a supply chain model or something where there's a network involved. And there's a really nice network package called NetworkX in Python for visualizing networks and things like solving shortest path problems on networks. And then hopefully I'd like to introduce, and if we don't, if it seems like this is not going to make it, I'll slide this in earlier, but just an introduction to containers, Docker, what are these things? How do they fit into the data science ecosystem? So that's kind of the goal. Again, it's kind of a combination of analytics stuff and software engineering things, because as we do kind of more programmatically based analytics work, we as analysts really need to become better programmers, and learning things like how to properly structure a Python project and how to deploy, create a package to deploy it, how to test, how to write documentation. So anyway, that's an overview of the topics in the course. And again, things are subject to change. Certainly, this first time around, we'll see how things go.